I hope you are doing good. So today we will take a new DSA question here, and the question is set matrix zeros. So let's understand the question first, and then we will discuss about the solution algorithms, right? So you are given a 2D matrix of size n cross m, and the task is to modify the matrix such that if matrix of I comma j is 0, in that case all the elements in the ith row and jth column are set to be 0, and do it in constant space complexity, right? So this is the thing you have to keep in mind. The extra space is not like cannot be used here basically, right? So you have to do it implicitly. Do not use the extra space. And let's understand the question here with example. So the question says, if for example in this case, right, in this case this 0 is here, right? This is the position where we have 0. So in this case, the respective row and column must be 0. So this column, this row, sorry, and this column should be 0. That is what it is saying, right? So see here, this complete column we made 0, and this complete row we made 0, right? So let's take another example here, right? So in second example, the 0 at this position and this position, right? So what does it mean? So what should be the output here? So the output is the respective row and respective column must be 0, right? So for example, this is 0th column, right? So 0th column, then we are making this 0th column to 0, right? Complete column. And 0th row, we are making this 0th row to 0, correct, for this one. And for this one, the next 0, this complete row is already 0, so we have to make this column also 0. So we are making this column also 0, right? So I hope you understood the question. So let's understand the approach. So if you are thinking different than me, then please let me know. Comment below the video so that we also get to know what you are thinking, right? So I have here two approach in my mind. One is with extra space, right? One with extra space, and in extra space, what we can do, so in extra space, for example, we can take a this is the copy of this one, right? So 1 minus 1 1, and minus 1 0 1, and then 1 minus 1 1, right? Here. So, and here what I will do, I will check basically this position I will check. If this position is 1, then I will not do anything. Then I will check for this position, minus 1. Yeah, next position, it means I from 0 to n and j from 0 to m. Basically, I will check each and every position. If it is 0, right? For example, in this case, it is 0. In that case, what I will do, I will update this. So you can say DP, this one. So here, what I will say, I will update this complete row and complete column for this position. So what I will do, I will make this 0, this 0, this 0, it is already 0, right? And this one and this one. I will make this 0. And then again I will check for here 1, so I will not do anything. From then here onwards I will check each and every position, right? And I found this is my updated basically matrix, right? So here you can see, right, this is the one, and I am taking this DP, or you can say temp, whichever you want, right? So this is a temp, basically temp matrix. So here we are taking order of n cross m extra space, right? So I hope you understood this one. Let's take the same algorithm with another example here, right? So this is the given example. So what I will do here, I will make separate copy of this given matrix, right? So 0, 1, 2, 0, then 3, 4, 5, 2, 1, 3, 1, 5, correct? Now what I will do, I will trace this from 0 to like 0th row to last row, right? Each and every position I will check. So see, I found this one is 0. So what I will do, I will make complete row and complete column for this position. So this position is I equals to 0 and j equals to 0, right? Don't worry, I will show you the code also for this algorithm as well. So this complete row, that is 0th row, I will make this 0, right? So I will make this 0, correct? And then I will make complete column 0 for this column, 0th column. So I will make this 0, right? Now I will check for this one, j equals to 1, then 2, then 3, right? So 3 also here you see 0 comma 3 is 0. So what I will do, I will make complete row to 0. So it is already 0, no, right? And then I will basically update the complete column to 0, right? So column is third, right? So I will make this one 0 in the update in the temporary matrix, you can say, right? And then I will check similarly, I will check for the other elements, right? So here we did not see any 0, so I will not do anything. So now this would be your basically final matrix. This would be your updated matrix, right? Where first this one is complete 0, this column is, and this column, two columns are completely 0, right? And here we have some elements, right? So I hope you understood this algorithm. So let me show you the code for this algorithm. So here the code, uh, I am basically here we are using the extra space, right? And time complexity is n cross m, and space also n cross m, correct? Order of n cross m, right? So here basically we are taking this extra matrix, right? Same size. I am just basically creating the duplicate matrix of this one, whatever the given matrix, right? And here I am using two loops to iterate the matrix, you know, right? I have explained it previous videos as well. And I am checking for the dp of I comma j is 0. If that is 0, in that case what I will do, I will update the matrix of matrix row and column, respective row and column in the given matrix itself, right? So here I have I have added the separate function to update it, right? So here I and j I will pass, right? So for example this one, right? So for this one I would be 0 and j would be 0, right? So I and 0, it means 0th row and 0th column must be updated. So for updating the 0th row and 0th column, I have added this function, and here what I am doing, I am updating the column, right? So in case of column, I will say that uh, uh, right, this j is fixed, right? Column is fixed, right? Column number is fixed. It means this column is fixed. The 0th column we are updating, right? So this one, so it is fixed, and we are iterating from first row to last row, right? And here I am updating the 0, correct? And here same I am doing for the row also. So row I is 0, right? So 0th row we have to update. It means this 0th row we have to update. So here column is fixed. See, uh, I is fixed, row is fixed, and now each and every column, first column, second column, third column, fourth column, it means we are iterating through the complete row itself, right? For the given row where we have to update, correct? So yeah, this is the simple algorithms, but it is taking extra space, right? And that is we do not want, right? In question it specifically mentioned that you have to do it implicitly. You cannot use the extra space, right? So if someone asks you the time complexity and space complexity for this question, this algorithm, then the time would be order of n cross m, right? And space also same, right? Space is also same n cross m, right? We are basically we are creating the duplicate matrix of this one, which is used here to solve this question, right? So now coming back to the second algorithms, which would be optimized one, right? Where we are not using any extra space, we are just using the constant space. Whatever is the given, we are just modifying that only, right? And that approach is what we will do in that basically. Uh, okay, let me write it here. So this is 1 minus 1 1, then minus 1 0 1, and then 1 minus 1 1, right? So here what I will do in this case, I will find the basically 0 and yeah 0, right? So here, so I will like basically traverse the matrix from 0th position, right? So this one, I will check first this one, then this one, then this one, then this one, then this one. If I found this one, right? So here for this 0, I would be 1 and j would be 1, right? So in that case, what I will do, I will make the 0th, like the first element of this column and first element of this row to 0. So what I will do, I will update this one to 0 and this one to 0. Right? Are you getting my point? What I will do, I will trace each and every element whenever I find 0. right, in the given matrix. Then what I will do for that position, I will check, yeah, if this is the 0, in that case just update the first element of that respective column and first element of that respective row to 0, right? So I am making these two elements to 0, right? And also, right, correct? So this is the one thing. The second thing is, I will keep track of the 0th row and 0th column. If is there any 0 in 0th row and 0th column, in that case I will keep track separately, right? So for that we can say separate, for example, row to false, right, and column to false, right, initially. But now, for example, if 0th row is having any 0 or 0th column is having any 0, in that case we will make these two true, right? So in this case, this would be false because the 0th row is not having any 0 and 0th column is not having any 0, right? In the original matrix, correct? So this is the separate thing. We will check this also. So now see, understand here. So I have updated 0th element of the column and 0th element of the row for the respective 0, wherever we find, right? Correct. So now after this, what I will do, and I will go ahead and check the other remaining elements as well, right? I did not find any 0 after this one. So what I will do, now this is the one thing. So now after this, what I will do, I will iterate for the basically complete rows, and once and the other time I will iterate through the complete columns, right? So after this, what I will do, for example, I will check all the columns, right? So all the columns, then I will check the initial value of the each and every row, right? So for example, this one. So this is not 0, right? It means this row is not having 0, correct? Then again I will check this one. This is not this is 0, correct? So the first element of this row is 0. It means this row is having 0 somewhere. That is why it is 0. So in that case, what I will do, I will make complete row to 0, right? So I will update this also, right? So now this complete row is 0. Now I will check for the this row. So this row is also not having 0, right? So I will not do anything else, right? Then I will check for the columns also, right? So for column, what I will do, I will check first element, it is 1, so no need to do anything. Then the second column, it is 0. In that case, it is 0, it means this column is having 0, original 0 in the original matrix, right? So I will make this complete column to 0, this one, and this is not 0, so I will leave it as it is, correct? I hope you understood. So let me write it here. What is the, so first I will basically traverse from 0 to n, right? This is for I, and for this is for j, 0 to m, correct? And here, if, uh, for example, matrix of I comma j is 0, right? In that case, what we are doing, we are basically two things we are doing. First element we are updating, right? So here matrix of basically I comma 0, and here matrix of 0 comma j, correct? 0 0, right? Are you getting it? Matrix of I comma 0 and 0 comma j, and first element of the column and first element of the row we are making 0, right? If it is 0, and other things what we are doing, we are basically keeping track of the row and column. If it is so, let me write it here. After this, so I will check if I 0. In that case, you can say row equals to true, and if J 0, it means column, you can say true, right? It means the first row is having 0 and the first column is having 0, right? That is what we are doing, right? So this is for the this one, correct? Now, after this, what I am doing, after this, I am basically updating the, so after this, so this is the first step. Second step, updating the column, right? And third step, updating the row. So row, I have explained you, right? If the first, I will check the first element. If it is 0, in that case update the complete row. If the first element of the column is 0, in that case update the complete column, right? So let's have a look into the code, and then we will basically run the code. So here you can see what I am doing. So this is our function. So this is our function where we are taking the n and m, right, from matrix, and I am taking this r and c boolean values to basically this will track the zeroth row and zeroth column if is there any zero in the zeroth row and zeroth column, right? So that is what we have explained, and then we have this for loop to track the to trace the complete matrix, right? If any element is 0, see here, if any element is 0, in that case, I will check for I and j. If I 0, then I will make this true, row true, and if j is 0, in that case, I will make c to true, right? Why? To track the 0 in the 0th row and 0th column, correct? And I will make the first element of the column. Right? See here, I comma 0. It means zeroth element in the respective basically row, correct? I row, and so this is for row, and the second is for column, correct? So zeroth element. So zeroth element in the row and zeroth element in the column. That is what we are updating each and every time whenever we encounter the 0, right? For respective position, correct? So this is what we are doing. So this is our first step, right? Second step, what we are doing, we are updating the 0 in the column, complete column, if we encounter the first element in the respective column is 0, right? So here I am checking 0 comma j. It means the first element in that respective column. That is what we are doing here, right? See, 0 comma j, right? It means this complete j, for example, j is 1, right? So 0 comma 1, that is this one, zeroth row and one column, right? First column. So here, if it is 0, in that case, we have to update all the elements in the to 0 in the respective column. That is what we are doing here. So this is second step. And for the here, right? This one, this is for row. This is same thing for row, right? So here also, if the first element of this respective row is 0, in that case, just update the complete row itself, right? So in this case, we are just updating the this one complete row, and this is complete column. That is what we are doing here. And here for 0th row and 0th column. See here, this is for 0th row, and this is for 0th column. So if the 0th row is having itself 0, so for example, that take another example here. So this one, right? Here, this one. So here, 0th row is itself is having 0, and 0th column itself is having 0, right? In that case, we will mark this R to true and C to true, right? Then after this, once we are done with the above steps, then we will check if it is true. In that case, just make the 0th column, 0th row to 0, complete 0th row, this one to 0, right? And this complete column to 0 if it is having 0 at the starting, right? Whatever, right? So I hope you understood the problem, you understood the code, you understood the algorithms. So let me run it here. So we have taken 3 comma 4 matrix, right? This one, this is 0 and this is 0. And see here, this complete column is becoming 0, this one, right? Complete row is becoming 0, right? This one, due to this one, and due to this one, complete column is becoming 0, this one, right? And then we have one more 0 here in between. So for this complete column is also becoming 0 for this one, and this complete row is also becoming 0 due to this one, correct? So I hope you understood this one. Time complexity of this one would be n cross m, right? Because we are traversing complete matrix, right? So this would be time, right? And here space complexity would be order of 1. We are not using any extra space here to basically get the solution, correct? I hope you understood the problem. If you want the code, complete code, this one, then please comment below the video. I will give you the link, code link, right? From where you can take this code and try it out. So that's all for today. See you next time. Till then, keep learning and keep exploring.